Now it is 26th problem from 2000 AIPMT. When an electron does transition from n is equals to 4 to n is equals to 2, if it is coming to first n is equals to 1, Lyman series. Coming to n is equals to 2, it means Balmer series. And it is coming from third to 2, first line, fourth to 2, second line. So we will go with option B, second line of Balmer series. So 26th, B option. 27th, it is from 2006 AIPMT. Ionization potential of hydrogen atom is 13.6 electron volt. It means in first orbit, its energy is minus 13.6 electron volt. Hydrogen atom in the ground state are excited by a monochromatic radiation of photon 12.1 electron volt. According to Bohr's theory, the spectrum lines emitted by hydrogen will be C. In ground state, energy of hydrogen atom electron is minus 13.6 electron volt. It got a radiation of 12.1. So where it will go? It will go at minus 1.5 electron volt. And we know that it is the energy of electron in which orbit? En is equals to first orbit 13.6, second divided by 4, third divided by 9. It is the energy in third orbit. It is divided by 9, you will get 1.5. So it means n square is 9. So electrons are in third orbit. So number of spectrum lines 3 into 3 minus 1 by 2 means 3. So we will go with option C, 27th C. 28th, it is from 2009 AIPMT. The ionization energy of the electron in the hydrogen atom in its ground state is 13.6 electron volt. The atoms are excited to higher energy level to emit radiations of 6 wavelengths. Maximum wavelength of emitted radiation corresponds to the transition between 6 waves are coming means it is in fourth orbit, 4 into 4 minus 1 by 2. And just we saw that maximum we will get when it will jump from second orbit to first orbit. Second orbit to maximum wave, no, that was frequency, maximum frequency, but they are talking about maximum wavelength. Maximum wavelength, it means minimum energy, because energy is inversely proportional to wavelength. In first orbit, its energy is minus 13.6. In second orbit, we are checking this. It is divided by 4, minus 3.4. In third orbit, divided by 9, minus 1.51 electron volt. In fourth orbit, divided by 16.85 electron volt, nearly. So if it is going from 3 to 1, energy difference is nearly 12 point something. It is nearly 12 point something. It should be minimum. 2 to 1, it is 10 point something, 10.2. 4 to 3, difference of them is 0.6 something. 3 to 2, nearly 2. So minimum energy emitted in 4 to 3 state. So we will go with option C. 29th, it is from 1990 AIPMT. The ratio of the radii of the nuclei, this and this, we know that radius is proportional to cube root of atomic mass number. It means radius and cube root of atomic mass number, it should be constant. For first nuclei, if radius is RAL, its atomic mass number is 27, cube root is 3. For 7th, it is TE. Mass number is 125, cube root is 5. So, ratio of radii of RAL by RTE, we are getting 3:5. Multiplying numerator and denominator by 2, you can write it 6:10. So, we are going with option A. 30th problem. Which of the following statement is true for nuclear forces? They obey the inverse square law? No. They obey the inverse third power law? No. They are short range forces? Yes. They are short range forces. Next, it is from 1990 AIPMT. The nuclei, this and this, can be described as C. Atomic numbers are different. They cannot be isotopes. Isotope of nitrogen, C and N, different symbols we are using. So, it cannot be D, it cannot be C. Atomic mass are different, it cannot be B. So, only one option is remaining. So, 31st, it should be A. Why A? Number of neutrons, 13 minus 6 is 7. And again in that, number of neutrons, 14 minus 7 seems. They are isotones. Next, it is from 1991 AIPMT. If the nuclear force between two protons, two neutrons and between proton and neutron, it is denoted by FPP, FNN and FPN respectively, then we know that these are nuclear forces. These are nuclear forces. And all neutron, proton, they are present in nucleus at same distance. So, forces should be same. 1991 AIPMT. In the nucleus of 1123 Na, the number of protons means atomic number. So, it is 11. Number of neutrons, difference of mass number and atomic number, it is 12. In nucleus, you will not find any electron, so it should be 0. So, 11, 12, 0, we are going with A. 33A. 34. It is from 1991 AIPMT. The constituents of atomic nuclei are believed to be neutrons and protons are there. So, we will go with A. 34th A. 35th, 1992. The mass density of a nuclear, it is independent of mass number. So, we will go with C. 36. It is from 1992. I told you that one atomic mass unit means 931 mega electron volt. So, we will go with C. 1995 AIPMT. The mass number of helium is 4 and that of sulfur is 32. We know that the radius of sulfur nucleus is larger than the helium by factor of radius is directly proportional to cube root of mass number. It means radius and cube root of atomic mass number. Mass number, it should be constant. For helium, R helium upon helium's mass number is 4. 4 is to the power 1 by 3 is equals to, for sulfur, its mass number is 32. They are saying the radius of sulfur, Rs, is equals to Rhe. into power is same, so we are writing in one bracket. It is 8, 8 raised to the power 1 by 3 is 2. So it is 2 times radius of helium. So we are going with C. 37th C. 38. It is from 1996 AIPMT. A nucleus ruptures into 2 nuclear parts which have their velocities in the ratio this. What will be the ratio of their nuclear sizes? See, we know that if nucleus rupture into 2 parts, linear momentum should be conserved. Initial momentum was same, so both will get momentum in opposite direction. If one's mass number is A, it is representing mass A1. Its velocity is V1. Second's mass number is A2. Its velocity is V2. Momentum's magnitude should be same. They are saying velocities are in the ratio of 2:1. If I am taking V1 to V, it should be 1V. The ratio of their nuclear sizes, it means A1 by A2 is equals to 1 by 2, but A1 by A2 is equals to radius ratio. We know that radius is directly proportional to 1/3 power of mass number. So from this relation we can say R1 upon R2, it should be equal to A1 upon A2 raised to the power 1 by 3. A1 upon A2 is 1 by 2, so we will go with option 1 by 2 raised to the power 1 by 3, means B option. 38, we are getting B option. 39, it is from 2003 AIPMT. The mass number of nucleus is always less than its atomic number, always more than its atomic number, sometimes equal to atomic number. See, I told you in case of hydrogen, 3 isotopes are there, 1H1, 1H2, 1H3. Mass number can be equal or greater than this. So, mass number of nucleus is always, we cannot use word always. Less, it cannot be less. So, we will go with option C. Next, it is from 2003 AIPMT. The volume occupied by an atom is greater than the volume of the nucleus by a factor of about, it is about 10 to the power 15. Mostly area is empty, only a small portion between the atom is occupied by nucleus. Next, it is from 2004 AIPMT. If we are saying symbol ZXA means Z protons, so ABC can be correct, and a neutron A minus Z. So we will go with option B. 2005 AIPMT. Which one of the following pair of nuclei are isotone? Isotone means same number of neutron, and neutron means difference of A and Z. So in this case, difference is 40. In this case is again 40. So A option is correct. In this case, difference is 46. In this case, difference is 48. So we got the option A. It is from 2006 AIPMT. Radius of germanium nuclide is measured to be twice the radius of barium. The number of nucleons means A, and radius is proportional to A raised to the power 1 by 3, means R upon A raised to the power 1 by 3, it should be constant for all elements. For germanium, we are writing it R germanium upon atomic number of germanium raised to the power 1 by 3. it should be equal to R barium divided by atomic number, mass number is 9 raised to the power 1 by 3. So A germanium raised to the power 1 by 3 is equals to 9 raised to the power 1 by 3. Mass number was 9 into Rge by Rbe. Take this on this side, this. They are saying the radius of germanium is twice the radius of barium. So this they are saying 2. So 2 into 9 raised to the power 1 by 3. No, R proportional to A raised to the power 1 by 3. R proportional to A raised to the power 1 by 3. The radius of germanium nuclide is measured to be twice the radius of, and for this, okay, we will check now. Taking cube root, we want AGE, take cube on both sides, so we will get 2 cube into cube of this is 9, 8 into 9, we are getting 72, so we are going with option A. Next, it is from 1989 AIPMT. The average binding energy of a nucleon inside an atomic nucleus is about, it is about 8 mega electron volt. 8 mega electron volt. Next, which ray contains positive charge particles? Yes, which ray contains positive charge? Only alpha rays. Beta rays, negative charge particle, no charge particle in X and gamma. So in this way, we have completed the 18th unit of atoms and nuclei. Thank you.